So first things first, on the 9 weeks exam, when it comes to linear, exponential, and quadratic functions, your best resource to study are the 3 understanding checks. Everything on those 3 understanding checks will be on the 9 weeks exam. Good afternoon, Lexi. There you go. Does anyone know, excuse me, I'm talking, does anyone know one concept that we have covered since the last understanding check that will be on the 9 weeks exam? The imaginary numbers,
solving.
but that was the last understanding check that I just gave back to you. So I'm just saying one thing that was covered since that last understanding check, the number I, okay? So be aware the understanding checks will cover everything. You need to know the fundamentals of linear, exponential, and quadratic. You need to know how to write the equation for linear, exponential, and quadratic functions and how to recognize them. So everything linear, exponential, and quadratic will be on this exam. Please note the second part here. This is what some of y'all really need to pay attention to. 5 of the 24 to 25 problems will be from the stats unit. 5 of those 24 to 25 problems will be from the stats unit. So note the majority of the questions are coming from what?
Quadratic.
Algebra 2, yes, but what did we cover in that second unit? Thank you. That first bullet point is the majority of the exam, but there will be some about statistics on there. That is exactly what will be on there from the statistics unit. Notice I don't have random sampling on there. I don't have biased studies. I don't have observational studies or anything like that. It's going to mostly focus on normal distributions, the empirical rule, and z-scores. Does anyone know of a resource that you could look at to help you study for those sets of questions?
Yes.
The book, yes, but also the test, right? There were questions just like that throughout the test. I would heavily look at those questions. I've already put the test together. One piece of clarification is this. You only have to answer 24 to 25 questions on the test, but there are going to be 29 on there. There are certain points where you're going to have decisions about which question you want to tackle, just based on your preference, right? I'll get and tell you there's a point where I give you 8 quadratic equations. You have to make a decision about which 4 or which 5. I haven't fully decided there, but you decide which 4 or 5 you want to solve. Okay? There will be a point where you have 2 different parabolas given, and you choose which one you write an equation for. So things like that. So there will be some choice in those matters. There will still be a short answer, a calculator, and a non-calculator portion. Okay. Questions, comments, concerns about those details? Group 6, do y'all have questions since we're talking so much back there? Hey, we're going to go over the understanding check. Like, we talk about things so much while I'm talking that we miss details. And it's starting to frustrate me because some people want to complain that they don't understand what's going on, yet they talk while I talk. It's mind-boggling. So, quick note about the e-learning day. I know that if you are a sophomore or a senior, you have an exam, or either the pre-ACT or ACT work keys, right? Tomorrow, so you don't have that full e-learning day. It is designed to be something that you can finish in one day easily for my class, but I'm giving y'all until Friday to get the mathy assignment done. Yes, you still have to do it. It's due by Friday. If you do it before Thursday, the workspaces I chose will be ones that help you prepare for the 9 weeks exam. So I would heavily recommend doing it before Thursday. Now, everybody needs your iPad out so that we can. Say again? No, I told y'all in class yesterday. If you don't have your iPad with you, look on with somebody. Yes, ma'am.
Mr. Kenny.
we finished up lesson 6 from the book, which was just solving quadratic equations, but when there's imaginary groups, and so we talked through what to do there. We'll see examples of it. Okay. What's up?
Where are we going?
Okay, so stop talking, pay attention. If you don't have an iPad with you, look on with someone who does so that you can see these details. Neither of you have yours?
Yes, I have it.
Okay, well I can't. Alright, so try to look on with somebody. So first things first, if you're going to go to Mathia, where do you need to go? Got to go to Clever first. You can either go to Safari for Clever, or you can use the Clever app. After that, to get to Mathia, you need to go to Carnegie Learning. So go to Clever and then Carnegie Learning. Yours will not look exactly like this, but it should look similar. You should actually see 2 different options of what classes to look at. You probably need to scroll all the way to the bottom. There it is. I would heart that CL because you're going to use that moving forward. Click on the little heart. Okay. I don't know what's happening. Okay. So when you're looking there, do you see 2 different options of classes to click on? So, when you see those 2 options, it's because one of the classes no longer actually works. You want the one on the right that says Fall Algebra 2 with Stats 3rd block. So you want to click on Fall Algebra 2 with Stats 3rd block, and where from there? Mathia, right? So click on Mathia from there. And so you should see 2 active workspaces. One called Normal Distributions and one called Solving Quadratics. Okay? You're in the wrong one. You went to the one I said. So you want the one on the right, not the one on the left. Okay, please listen. The Normal Distributions. Click on where it says Let's Go. It says 0 of 7 workspaces. You do not need to do all 7. You just need to do those first 4. Okay, notice the first 4 is all about relative frequency histograms. It's about empirical rules, z-scores. That's to help you practice for the 9 weeks exam. Only do the first 4 under normal distributions. Only the first 4.
Wait, only the first 4 under which ones?
Normal distributions. So only do the first 4. So go back to your modules really quickly. So yeah, just log out of that at this point. Or go back to the modules. You need to do all of the solving quadratics. Okay? You need to do all of the solving quadratics. So how many of normal distributions?
4.
First 4. How much do you need to do with solving quadratics?
All 2.
Both of them, right. Yeah, all 2 of them. Okay. When is this assignment due?
Friday.
Friday. Okay? Please hear me very clearly on this. I cannot tell you how long this assignment will take because the way that Mathia works is it adapts to what you're struggling with and what you're doing right. So if you're blowing out of the water and getting it right every time from the get-go, you're going to get through very quickly. If you're struggling, it's going to have you keep working until you master it. And so, if you are struggling, I need to say this very clearly. I've heard from a couple of students and at least one parent who's talking about, hey, my student is spending a couple hours on homework. Now, I haven't assigned too much homework, so that doesn't concern me too much. But I will say, I have not had a homework assignment that is designed to take more than an hour, really 30 minutes, 30 to 45 minutes. If you are spending way longer than 45 minutes to an hour on a homework assignment, pause there, come into tutoring. The other thing I'll say is I've seen a lot of people struggling with homework assignments and then I say, hey, did you go back and look at your notes in the book? Well, no. Well, the reason why we took notes is so that you had something to refer back to. Did you check out the videos on YouTube, right? There are these things that are there to help you be successful. Don't sit there and just struggle. Be efficient with your time. Is that clear? So, work smarter, not harder. If you're struggling with something, come in and ask questions. Y'all literally have me for enrichment. Take advantage of that. One thing I will say with the mathy assignment, do not try to do it exclusively on the computer. Write down your work. It is really hard to do a lot of this math in your head, so quit doing it. Follow the directions on Mathia. It'll walk you through different details. If you run into issues, please shoot me an email and I'll be happy to help you out. What are your questions before we get to going over the understanding check? All right, all iPads up. Time to look at the understanding check.
Oh, yeah.
Yes.
So am I supposed to be writing it, you know, on this?
Say again.
Okay, well, you first have a class, you got to finish it.
So, yeah, your best bet at this point is to just take notes and learn from your mistakes so that you do better on the test. I know you didn't quite finish, but this is at least feedback. You started out well, right? So, learn from that.
Miss Kenny, when is tutoring again?
Yes. We're going to talk about that. Track one. Thank you. All right. Let's talk about this understanding check. I need this to be a very clear thing. All right. Some of us in this class are doing an excellent job of being a part of whole class discussion. However, I am starting to get frustrated, and I'm not going to call them out by name, but I am getting a little frustrated with a handful of us who are not participating in the whole class's conversation, and then we're having our own small side conversations and missing the exact things that you need to hear. Be a part of the whole class discussion. Actively engage, ask questions, share your thoughts, push understanding. There's a lot to learn. Yes. All right, so note about e-learning day is done, understanding check time. So first things first, we need to be a little bit more strategic about how we're approaching these different equations. And what I mean by that is, how many different methods do we have to solve a quadratic equation? Trace. There are only 3 equations up here. And I intentionally chose these 3 equations so that there was a best method for each one. And so I recommended that you identify the method that you choose first. So consider this. Which of those 3 methods is the most restrictive, meaning it works in the fewest cases? Factored form. No, you're good. I like mistakes. It's okay, but we want to learn from that. Why is factoring, and I will say this, vertex, we do want a nice value for the x value of the vertex, but you can still always use it. That's one thing to clarify. You can always use vertex form, it's just not always going to be pretty. And that's something to consider. But does anyone remember what has to be true in order to use factoring? So A times C equals B is what I heard? Anybody want to push back?
Factors of A times C
So,
must add up to B.
Factors of A times C have to add up to B. We got to know that. To use factoring, factors of A times C have to add up to B. By the way, don't forget guys, this is your understanding check. Take whatever notes you need to on it. Did I give you yours back, Sammy? Maddox, did I give you yours back? Oh, Zany, yours is right here, my bad. I'm glad I noticed that you didn't have yours out. Ask me. Okay. So to use factoring, factors of A times C have to add up to B. But I do want you to also remember, what's the point of factoring? So that we can use what? The zero product property. Remember, distributing would actually get us back to standard form. The whole goal is to be able to use the zero product property. Would any of these equations give us a problem in using zero product property? Two of them would.
2 that don't have 0 though.
A and C, right? Are they set equal to 0 right now?
No.
No. If we're going to use the quadratic formula, if we're going to use factoring, you have to be equal, or the equation has to equal 0. That's the starting point that a lot of us miss, and it messed us up, and I tried to make notes of that. But learn from it if you didn't do that. So when I look at A, what is the first thing I need to do? So how am I going to make a 0? 1 minus 1 is 0. You should have had x squared minus 4x plus 3 plus 2 is equal to 0. If you didn't have that, you were going to run into some trouble. Some people tried to factor, which you could factor x squared minus 4x plus 3. You cannot this one, and we'll talk about why in a second. But you need to pay attention to that. The standard form has to equal 0 to use factoring. So at this point, if I'm not sure, I need to do a times c. 1 times 2 is 2. Are there any factors of 2 that can add to negative 4?
No.
That's a negatory. So am I going to factor here? That's a negatory. All right, so I'm going to go to B and C. Notice I'm not going to just try to find another method for A. We already said the most restrictive, the one that we can use the least often is factoring, right? So I'm going to check B. It's already equal to 0, so I'm good. A times C is negative 8. Any factors in negative 8 that add to negative 7? Right? Negative 8 and 1. So those are things we want to pay attention to. Think through the factors of 8. 1 and 8, 2 and 4. Any combination work? Yeah, negative 8 and 1. So what method am I going to use on B? Factoring, right? I've got it there. Now I'm going to pause, and I do want to point out, I'm going to look at C now. What's the issue on C? It's not equal to 0, so I'm going to subtract 1. Because even if I end up using the quadratic formula, what does the equation have to equal to use quadratic formula? There is, and I'll go ahead and tell you, hold on one second, I'm going to talk about one thing. There is one method, thank you. There is one method that you don't have to equal 0. Does anyone know which method you don't have to equal 0 for? Let me check your work again. Yes, you are correct. I did forget to tell you that. Let me check your work, see if I can give you credit or more credit than what you earned. I thought I tried to read with it if I noticed that, but I may have forgotten to. Yes, Jordan.
You subtracted 1?
Yes.
Why?
Oh yeah. You were gone. You and Aaliyah were gone. I think when I gave you all this information, that it was supposed to be a 1, not an 8, and I made that mistake. Yeah.
I never got that.
Well, you didn't pay attention then, because
No,
I told you.
I already did it.
Oh, you-
Oh, that's right, that's right. You're right, that's right. I do remember that now. But I think I read with that, didn't I? Yeah. I tried to read with it if you didn't notice that or if I forgot to tell you. But anyways, looking up here now, when I look at this, negative 2 times 4 is negative 8. Are there any factors in negative 8 that add to 3? Oh, yes. What's the only method that does not have to equal 0? Vertex form. Because you're just going to use inverses with vertex form. But if the other two methods need to equal 0, it would probably just be a good idea to make sure that the standard form equals 0 every time. That's a good habit to be in. Because if you're going to factor, it needs to equal 0. So just go ahead and make the quadratic equation always equal 0. Yes, Lexi?
So is it okay if you did make the vertex form equal to 0?
Yeah. I'm just saying that's the only one you don't have to. Yes, you can always make a quadratic equation equal to 0 because it's still equivalent. It's just vertex method is the only one that doesn't require the quadratic to equal 0. Yeah. Okay? So, anyways, factors in negative 8 that add up to 3? None. So please note, there was only one equation that you could use factoring on. It's the most restrictive. Start there. Questions about how I identified where I was going to use factoring? So strategically choose factoring here. From what's left, which one should I use vertex form on and which one should I use the quadratic formula? Okay, so what here is telling me to use vertex form?
The B, because it's,
The negative b over
Negative b divided by
2.
Remember, that's the x value of the vertex. X equals negative b divided by 2a. That's the x value of the vertex based on standard form. And when I look at this one, I get, what's the opposite of b? Divided by? And ends up equaling 2. One thing I will point out, both for vertex form and for the quadratic formula, it's not a bad idea to identify what A, B, and C are. Helps make sure you don't make mistakes. Okay. So vertex form would be nice here. If I look over at this one, x equals the opposite of b divided by 2 times a.
It gives you like a fraction, doesn't it?
Negative 3 divided by 2 times negative 2 is equal to 3/4.
Yeah. No.
And you have a calculator. Could you use the calculator to substitute that 3/4 in? You can, right? But you can use vertex form there, but it's just easier to not stress about fractions. That's it. It's easier to not stress about fractions. So I would have used vertex form here and quadratic formula here. Okay. Again, strategically choose which methods you're going to use where. Be intentional about those things. Any questions about how to identify which method to use in which situation? Okay. Going once, going twice. Sold. All right, so we already said factoring. And we've already identified the fact that what are the factors of A times C that add up to be B? Negative 8 and 1. Okay. So I'm going to just show you the work and I'm going to let you ask questions. Here's the work that I did with that method. I'm going to let you ask questions from here. Y equals A times B raised to the X. Raised to the X. So no questions on this factoring one now? Yes, Jordan.
Well, I didn't factor on that.
Okay.
I did that.
But do you understand why we would want to factor now?
Yeah.
And I will point this out. I had some people who tried to factor on other problems and used quadratic formula here and did that successfully, right? You can use quadratic formula on anything, but I will point out what kind of zeros are these at the end? And remember the name for these types of numbers. They are roots, but just that type of number. Are they integers, irrational, rational, real, imaginary? Irrational?
One of them are rational.
They're rational. Remember, rational means ratio. Isn't that a ratio of -1 to 2? 4 is understood to be a ratio of 4 to 1. So those are rational numbers. If you end with a rational number, you could have what? Factoring. If the roots are rational numbers, you could have factored every time. Yes, Maddox? Okay. Yes, Jordan?
Okay, I got what you got,
Okay.
but my number was negative.
Say again.
I got negative for it. No, I didn't. No, you got it. Please.
I got positive 4 and -1/2.
Okay, I got negative 4 and positive 1.
Gotcha. My guess is that you made a small mistake somewhere, accidentally changing signs. Remember, it's the opposite of B. Negative B, so it should have been a positive 7 there. That's the only mistake. Okay? Does that clarify that?
No, wait, why would I do that?
Okay, so really quickly, if we're going to use a quadratic formula, what method or what's the equation for quadratic formula? So, Jordan, notice how it's negative B, which means the opposite of B. If you're using quadratic formula here, that's a -7. What's the opposite of -7? Positive 7, right? So that explains why you got those backwards. Any other questions about factoring here, investigating our mistakes? Or if we didn't factor, Do we need to ask any questions about how I factored here? Not, I'm moving on in just a second. I'll answer that in a second. Lexi, you had a question?
I'm kind of confused.
Okay.
Is what you have on my paper, I had already did, and I guess I put my two x's into an equation, kind of.
I'm just gonna look at that in a second. See what you're talking about. Logan, how did I get to 1/2? So, do you understand how I got this factored form right here? Yes? Okay. Remember, and I will point this out, I need y'all to look at your sheets again. There were a lot in this class specifically who did not write equals 0 throughout this point. But remember, the whole idea is that if I have factored form equal to 0, then I can use what property? Zero product property. That's the whole point. If it's not equal to 0, you can't just magically set these equal to 0. The whole point is that it needs to equal 0. Now I can set my factors equal to 0. And so here I add 4, and x is equal to 4. Here I subtract 1, and so, Logan, this will start to answer your question. I need to undo that multiplication by 2, so I multiply by 1/2, 1 divided by 2. Right, because 2 divided by 2 is 1. Does that answer your question? So remember, I use the reciprocal. Instead, you can do divided by 2. It'll give you the same answer, but I always use that 1/2, the reciprocal, to help build connections. Lexi, did any of that answer your question, or do I need to still come and look at yours? Maybe? I'll come and look. Alright, last questions about this factored form method before we look at the vertex form method. Yes? Okay, that is a good question. Does anyone know how we could check our solutions if we use quadratic formula or a different method? You could graph it and look for the what? X-intercepts. Remember, it's set equal to 0, meaning that the y is 0. You can always graph it and look at your x-intercepts. Also remember, those should be solutions, meaning they make the equation true. It doesn't matter what method you choose, you are looking for a solution, you're looking for what makes the equation true. And you can also graph it and look at the x-intercepts, either one. Make sense? Okay? And that's a good point. A lot of us very clearly did not check our answers. Check your answers, guys. Please. Alright. I think that's it for that. Okay, so looking here, A is where we said we're going to use vertex form. Don't forget, if we use vertex form, what's the goal? Why do we want the vertex form? Remember, the vertex form you can always use inverses with, right? So the vertex form you can always use with you can do inverses with. Yes, that was the issue right here, because that's not factored form. That's factored form, right? You put roots back in, but the factored form is the 2x plus 1. If you put a 2 out in front of here as your a, that would have worked. You see how you have an a of 1 when it should have been a of 2. Does that make sense? That was the issue there. And that was more why you had a C+, because it's still mostly correct. And it was something we haven't covered, because I wasn't planning on getting into that, but it's still mathematically incorrect. And so I wanted you to learn from that. Okay, the whole goal is to use inverses. Here's how I worked it out. Notice all of this work along here is just to say, hey, I can't factor. I did have different numbers originally. I changed it to make your life easier. But x equals negative b divided by 2a. So remember, that's the x value of the vertex, which is h. Once you have the x value of the vertex, what do you still need? The y value. So how are we going to find that? Substitute it in. X is what's another word for that x value? It is a variable. Which one is it though? Is it my input or output? It's my input. I substitute my x in to get my y out. That's this work right here. Just substituted that positive 2 in to get out my negative 2 for k. Substituted in my vertex formula, or my vertex equation, and then solved using inverses. What are your questions about that vertex form? None? Feeling okay about it?
Wait, I have a question.
Yes, ma'am. What?
I thought someone else said
I thought,
something.
didn't you say you had a question?
Yeah.
Okay, I didn't hear anybody else say anything.
Okay.
What's up?
Okay, so when I added my 2 in,
Mm-hmm.
did you wrote there so I can see it? What did you get?
When you wrote your what in?
When I plugged in, wait, I got positive 2, okay.
So I got 2 comma negative 2 for h and k, right? But remember the vertex form is a times x minus h squared plus k. This is why we covered the different forms of quadratics so heavily. We've got to be careful. A is 1, and we have to remember it's x minus h, so it's x minus 2 squared plus a negative 2, so minus 2. Does that make sense? Was it the setting the equation update? Like, did you get this part?
No. I didn't do that part.
What'd you do?
I know I got frustrated, so I did Quadratic Formula.
Oh, you used quadratic formula. Did you get the 2 plus or minus square root of 2?
No, I got 2. Well, okay, I got h. But I don't see. Look, I don't know. Cause I just tried to remove it. But I got 2.
You don't put the equal 0. 4 minus 8 is negative 4. Negative 4 plus 2 is negative 2. So that is a good point, guys. Don't forget when we're using the vertex form and we substitute in, we're not setting it equal to 0. We're substituting in for x to get out the y. So you can either just do this or you could say f of 2 equals, either way. But you're not setting it equal to 0 yet because you're not solving the equation, you're just getting the vertex form. You need that y value of the vertex, which is an output. Jordan, stop stressing it. I put in, substituted in the 2, what I get out is negative 2. That output is k. It's the y value of the vertex. Yes, Chelsea?
On A, the x equals 3, whatever, 3.414, how did you get to that?
I mean, I just put in 2 plus the square root of 2 in the calculator.
Was that
You can stop at 2 plus or minus square root of 2, but in case someone got the decimal version, I went ahead and wrote it down so that I knew what they were getting if they did it correctly.
Oh, you were still plus and minus.
You're right. Because remember, it's plus and minus, so it's 2 different roots. Okay. So last one, quadratic formula. I need y'all to hear me very clearly on this because I think I mentioned it yesterday. I realize now that this is why I dislike the quadratic formula. We are messing it up because we have not memorized it or learned it correctly. 2 things. Do not write this. What's the issue with that? It's all divided by 2a. Right now, you are only doing b squared minus 4ac. Is that Clay? Yo, tap that man on the shoulder and wake him up. Clay. Right now, we're only dividing either the square root or just the b squared minus 4ac. Right? That is not correct. The whole thing is being divided by 2a. Secondly, write your fraction bar as a horizontal line. That'll help make sure that you don't make that mistake. I saw people writing this. Right now, what does it look like I'm dividing by 2a? Just the 4ac or just the b squared minus 4ac? Write your fraction bar as a horizontal line so that you're dividing everything by 2a. No. No, and I even have to erase all that before the pre-ACT tomorrow, so it won't be there by the time you take your test. You got to know your forms. You got to know the quadratic formula. Yep. Sure, use some note cards, you'll get some practice with the mathy stuff. From here, one of the biggest things I do want to point out is, again, to use quadratic formula, it has to equal 0, right? A lot of us need to slow down and pay attention to what A, B, and C are. A is equal to what? -2. B is equal to 3. C is equal to? Ooh, so you need to be careful. You can only use the quadratic formula when the standard form equals 0. You can't use this 5 because it's not equal to 0. So that is something to be aware of. To use that quadratic formula, the C, or the standard form, has to equal 0. So C was equal to 4. Another thing is, and this wasn't 1 or 2, this was multiple students that I saw put -2 in here for B. Is B -2? No, it's 3. B is 3. Make sure that you write out your A, B, and C to make sure you just don't make that error. That's a massive procedural misunderstanding. It's going to drop your score on that rubric of understanding. All right.
Why does one have to equal 0?
The quadratic formula doesn't work otherwise. There's a reason why that goes back to what's called completing the square. But the proof for it just would take too much time. So there is a proof for it. I'd be more than happy to sit down with anyone during tutoring. But the quadratic formula doesn't work unless that standard form equals 0. Yes, Chelsea?
Can you get this thing off there so we
Yeah.
can see the bottom of the
I will point out you can stop right here. Again, I only got those decimals in case someone got that far. But this fraction is all you had to do.
Would it have been -3 plus minus -3 divided by -4?
Can you go back? Or the same?
You know what it is?
We'll go back to it in a second.
Yeah, 2 seconds.
Yes, Lexi.
So I did all of that right, but I put that I couldn't have used vertex. Can you explain that? Not explain, but wrote why I couldn't.
I'm not saying you
why-
couldn't.
Why it would be a lot harder. 'cause
Yeah,
you
yeah.
found that.
So the one,
Yeah.
that's
Says
the answer
this
when it wasn't
for the whole thing,
both of
just
them.
because I wrote that.
Well, and maybe I shouldn't have done it here. It was more, because I was trying to, the part of the assessment was also you understanding what form was most efficient in different places. So yes, now, on the test, you can use whichever one, but I wanted to see that you understood when each method was most efficient, which is why it was a C+. Yeah. Yeah.
Nicole.
Now, don't put the fraction bar under the x equals. Okay. All right, really quickly, I do want to point this out because I know some of us did this equation equal to 8. 2 quick things I want to point out. First off, before I get into this answer, I do want to point out if it had been -2x squared plus 3x plus 5 equals -3, what would I have done in this case? I'm just making this up, but if I was trying to solve this equation in pink, what would I need to do first? Okay, I just want to make sure that's clear, right? It's not always subtracting. In this case, we would need to add to make a 0. Okay, so sometimes you end up adding because you're trying to create a 0. Don't forget that. Secondly, I didn't need you to go further than this on the understanding check, but on the test, you would need to go further than this if you are working this problem. Why is that?
Oh yeah, because we can do the imaginary.
You can now do the square root of a negative with those imaginary numbers. That's something to be aware of. You don't necessarily need to write this on the understanding check, but how would I handle this if I want to write it with the imaginary number I?
It's negative.
Square root of -1 times
59.
divided by -4. Remember, I'm going to take extra steps to make sure I get it right.
Yeah.
So -3 plus or minus
Square root of -1 times square root of 15.
divided by,
-4.
and finally,
Plus or minus I, -15,
And that's where you could stop. You would have to get to that I there
And you can't do
on the
anything else.
9 weeks exam.
You're done right there.
You'd be done
What
right
if it
there.
was a
But
number
it
that,
doesn't
what if that
come
15 was like
Perfect square.
36?
Then take the square root and get your 6 there.
Negative 3 plus or minus I times 6.
Or 6i divided by negative 4. Yes, Jordan. And then I'll go to Amari. She's had her hand up for a while.
When you did -1, is that supposed to be the I?
Well, the square root of negative 1 is I.
So that's why you changed the 15 to a 5?
Yeah, so, well, I didn't change it. I rewrote negative 15 as negative 1 times 15. So when you have multiplication inside of the square root like this, you can split it into 2 square roots. So I get the square root of negative 1 and the square root of 15. So that becomes my I.
Okay.
Does that make sense? That's what we spent all yesterday on. Yes, Chelsea?
So you saying on the 9 weeks exam, you want us to be able to prove that
Get
we
I.
can do that?
I want you to be able to get I on the 9 weeks exam. That, you don't have to simplify the radical unless it's a perfect square, go for that, right? Square root of 36 is 6, square root of 16 is 4, stuff like that. But if it's something like square root of 15, just leave it, okay? All right. Questions, comments, concerns, final ideas before we move? Good. That's why I go over these things, because it doesn't matter how you did the first time around, it matters how you grow and learn to master it moving forward. All right, we are moving in the textbook to Module 1, Topic 2, which is on page, and we're going to Lesson 2.
Really no. Look for it, right?
Page 139. What's up? No, I got 2 over there. All right, page 139. Slightly new idea now. Bree, you awake back there?
Oh!
Oh my God.
Give me one. I need to
If you get her,
Hey James, did you forget to put up your phone when you came back? And Mark? And Bree? Where's your phone?
He did put it.
when I start getting
Who did?
Stop shaking it.
Oh, got it. Bree, where's your phone? Okay. And 5, oh, yeah. Okay. All right, so we're on page 139. So what we're looking at is transforming functions. Does anyone remember the transformations that you have studied in previous math classes? Transformations. You don't remember that term, transformation?
I have no idea what transformation. You said page 139.
Yeah. M1-139.
Oops.
M1-139. Alright, so the red is an example of a transformation of the blue. The black is an example of a transformation.
I still don't remember. When
Say
should we
again.
have done that?
Both 8th grade math, geometry, and algebra 1. One of the transformations is called a what? Translation.
Are you sure we weren't?
No, we're going to use this in a second. Yes, ma'am.
We never finished everyone.
Okay, but 8th grade math, geometry, and algebra 1.
Doesn't count.
And I'll leave somewhere in there. No, I'm just saying. So,
None of us.
that sounds like an excuse instead of learning how
It
to
is an excuse.
master things. Alright, so, translation means that it's, what's another word for translation? Well, it would map, but, okay, more mathematical than move is shifting, but it's called a translation, right? People typically think about translations as shifts, okay? An example here is if I let the blue function be y equals x squared, the red one might be y equals x minus 3 squared. What mathematical operation created that translation?
Shifting.
Right. The transformation on the graph is a shift or translation. But what operation in the equation caused that translation? Subtraction, which is a type of addition. Addition and subtraction are what creates translations. That's a transformation. Okay? Yes, Amari. Yes. Good question. Test stops at imaginary numbers. This is not on the test. Remember we made that deal that I would let y'all have more time to come into tutoring and study, but we have to move on with the content. Okay. So, adding and subtracting is a translation. That's what I want you to notice. This black function here, anyone remember what that might be called? There's a couple different words you can use for it.
Give me the letter that starts with.
It could be a D or it could be an S.
Dilation.
Dilation.
Wow, that's
Okay, stretch. Yep. So, dilations, listen, dilations either fall under stretches or under compressions. Okay? So, what we could see is this point right here on the blue maps to here on the black. See how it was stretched vertically up? Okay? So we see dilations there. And so we have dilations that are stretched or compressions. Any guess what would cause mathematically this dilation like that? Or, in this case, it would be something like 3x squared. Multiplication is what's going to cause a dilation. And so we need to be aware of those two things. A translation is caused by what operation?
Addition or subtraction.
Addition or subtraction. It could be, because remember, subtraction is a type of addition, just adding a negative. And dilations are going to be caused by multiplication. Okay? The only other transformation that you did study, but we're not going to go into a whole lot right now, is reflections. Do you remember that a little bit, hopefully? Alright. The focus right now, though, is to describe the relationship between linear factors of a function and its zeros. So we need to know this little bit of background about translations and dilations to get into this lesson, which is why I went over those details. It's not the focus, but you need that background to be able to do this set of problems. Okay? So here is my focus, right? There's these objectives or learning goals for the book. I am breaking it down into two major things. You need to be able to use the factors of a polynomial to sketch the polynomial. Does that mean you have to be super accurate? No. But there are some key points that you definitely need to get and understandings about how those things work together. And then we're going to connect intervals of increase and decrease and zeros with the linear factors of a function. What's up, Cannon? You good? They're kind of important for polynomials. Alright. You good? Guys? Okay. So, here's what we're looking at. A functional transformation. This is the next page, page 140 in the book. They just like, get me out of here. Hello.
What did you drink?
Okay, sounds good. No problem. Bye. Alexandria, they need to see you for a second at the office. You'll be back, is what it sounds like. Okay. So. Sorry. Alright. Consider the constant function f of x equals 3. What's another variable we could use for f of x? Y. So when we. So go ahead. What do you say? It is a linear function. This is a special type of linear function, a horizontal line. But notice, what does every point on this line have in common? The y is always what? 3. So it's not just on the y-axis, it intersects the y-axis. But look, this point right here is 1, 3. This is 4 comma 3. This is -1 comma 3. Right? It doesn't matter what point you choose, the y value is 3. And so we're going to transform this function by, what does it say? Recall that you can translate this function, what does it say? Vertically, right? By adding a constant. But that would, all that would do is if I translate it vertically, I would still get a horizontal line, right? That's not going to change it very much. And that's kind of the point of translating and dilating by adding, by constants. Notice, isn't this basically the same parabola, just shifted to the right? This one's just stretched up. Well, what happens when we start transforming by variables instead of constants? That's what this question, or this module is about. Well, a constant would just be a number, 5, 6, or 8, or something like that. But if we're transforming it by a variable, we're going to look at something like x.
That can change?
That can change, exactly. So here's what we're doing for that. Number one, we're going to work through this together. Make sure you're engaging, ask questions if I'm unclear. But, what's up?
Why wouldn't you transfer to the left?
Well, remember, it's x minus h, so h is a positive 3. Right? And so remember, everything horizontal acts the opposite of the way it appears. Good question. Does that make sense? Okay. So, number one. Consider the point of the original function at x equals 1. This point has coordinates 1, 3. Plot the location of the point after a vertical translation of x. So, a couple of details. If it's vertical, which variable is that going to affect? Which one is it? I heard y, but I heard x. If it's going up and down, that's y, isn't it? I know, but we're taking that horizontal line and we're vertically translating it, right? Okay, so it's vertical, so we're only affecting the y, and it's a translation, so we're using what operation? Addition or subtraction. There we go. And what are we adding or subtracting? The x. Doesn't every point have an x value?
Yeah, that's
Right? So let's look at this. If I'm looking at 1, 3, the x of 1 stays the same. But I'm going to translate the y by adding the x. What's 3 plus 1?
4.
So then I would have the x value still is 1, but the y value is 4. So once we translate, I would no longer have 1, 3, I'd have 1, 4. What are your questions about that detail? Jordan's like, I'm rocking with it, Mr. Kenny.
Wait, why did you do that?
Because of the directions for number 1 says plot the location of the point after a vertical translation of x. So I took this point 1, 3. I'm only affecting the y, but I'm taking the y value and adding x to it. 3 plus 1 is that 4. So the x stays the same, but the y is translated up by the value of x. Does that make sense?
Well, you get one to the left side.
Well, that's what we're about to look at. Consider the point of the original function at x equals -1. This point has coordinates -1, 3. Plot the location of the point after a vertical translation of x. So, what would happen to -1, 3?
You add.
Right here.
Oh.
You read it.
Is
It's in your book.
Oh.
Where you
Page
going?
139.
I'm on, no, I'm on page
140 now, yeah. It would still be an x value of -1, right?
Yeah,
How'd you get 2?
because
-1, 3, we're taking the y value and translating it by the x. So we're going to add -1, which gives me, well, positive 2, right? Because 3 plus a -1 is 2. Huh? Right. So what is 3 plus a -1? 2.
I'm saying it right the one.
Oh.
You said you can make it
It's negative?
Oh, thank you. I didn't, you're talking about that right there.
That, no,
Well, yeah, that is the point, -1,
Okay,
2.
now I was confused, I thought that you were trying to say it was over there.
I got you.
It wasn't.
No, it'd be -1, 2. The x does not change, just the y is added by the x. So plot some other points after applying a vertical translation of x. So let's look at these points that we already have.
Let's do the
What would 4, 3 be?
4 plus 3, so it'd be 1, 7.
Wait.
1, 7?
That'd be all up.
What would that point be?
Oh, not 1, it'd be 4, 7.
So remember, we're taking the y value and adding it by
Oh.
4. So the x stays the same. It's only a vertical translation. 4, 5, 6, so a little bit higher, 7. What would -4, 3 become? Anybody want to push back on or ask a question about -4, -1?
I think so.
You think you want to push back on it, or you think that's correct?
Wait again.
Well, Grace Ann said -4, -1. My question is, does anyone want to push back on that or ask a question about that,
Well,
Jordan?
are you subtracting or are you adding?
That's a good question.
Because if it's, but if it's negative, you're restricted.
Well, but so you would be adding a negative,
So
which
are we
is
doing
this.
negative 4 plus 3?
No. Remember, we're taking the y value and we're translating it by x. So we're adding a -4, or just 3 minus 4.
Go back. Go ahead, reverse.
Reverse Uno? Like, what do you mean?
Go back.
Go back to what?
I hate the reverse card, dude.
Sorry. All right.
No, I agree with Grace Ann.
You're even Grace Ann. Anybody want to push back on or ask a question then?
Look,
Push. You take your y, translate it by x. 3 plus -4 is that -1.
So you're why?
Yes.
I'm not.
Chelsea, you got a question?
I don't know, like, cause I don't even know what I'm trying to ask.
Oh, you talking about you?
Okay, remember, we want a vertical, so we're affecting the y. Translation, meaning we're going to add whatever x is.
No, why are we doing that to get what?
Huh?
Why are we doing that?
I can't hear you because people are talking.
I said, why are we doing that? Like, what are we trying?
Because the directions told us to. And we're trying to find a pattern or relationship because it's math, but we're following the directions right now. Okay? So I get you on that, but hear me on this. Follow the directions, and then we're going to notice a pattern here. Remember, originally we had what type of line? Horizontal line. Do we still have a horizontal line? So, remember how I mentioned it earlier that we've always done transformations by constant values. The question is, if we transform by a variable, does that change the function? And it does. It went from being a horizontal line, which I'll go ahead and show you. I think they talk about it. No, they do not. A horizontal line is known as a polynomial with degree 0. But here we have a line with a slope on it. What's the equation of this line? Well, that's in general. So what's my m? What's my slope? But what is the slope?
Oh,
3.
Okay, guys. Even if you're going to say that, it's up to the right 2. Use right and left. And then it's 2, not over 2, 2 divided by 2, which is 1.
And put our x graph going.
Say it again, Olivia.
Isn't it our x graph?
I can't hear you.
Our x-axis, isn't it going by 2?
yes.
No, so it's 2 over here, but every block is 1.
Okay.
They just didn't count the one.
They just didn't show that number 1. And then what's the y-intercept? Hey, remember how we just kept taking 3 and adding x to it? That's why that's the equation. X plus 3 or 3 plus x, either one. But more importantly, does anyone know what the degree of this polynomial is? It's no longer degree 0.